Hi again. This is the latest project. It's a Loewe-Opta, German, very good brand for their day and beyond. This is a model Truxa Stereo, more specifically the 4741W. Now this radio isn't mine, it's belongs to a friend of a friend. So I received it like this, with some cleaning having been done on the chassis. It's been polished and actually looks pretty good. You can see the aged patina on it, which always gives it a nicer look. There's the obligatory gold stripe that you see on most of these old radios, the German ones at least. No chips, nothing dramatic on the chassis or the cabinet. So this should be fun. This is more an electronic restoration than cabinet and cosmetic, but we'll do some of that as well. There's a little bit of staining on the grill cloth. Some of these borders here have been cleaned. We'll complete that. The head of that knob has gone. We'll have to find a solution for that one. And the only place where cleaning is evidently needed so far is the buttons. Now this radio is a stereo, 1959-1960. My guess is that it's stereo for the phono input only. I don't believe they had stereo FM at the time, but we'll see. It has a magic eye there as well. We'll see if that works. This hasn't been turned on yet. And we'll take it one step at a time. There had to be a catch. This is the inside, as you can see. And this one's been stored. I think this is good old-fashioned Madeiran dust. Lots of it. Oh dear. Okay. When I saw the outside, I thought this would be different, but it would be too easy. So it makes it more challenging, I suppose. Lots and lots of dust. We don't know what we have in here. So there'll be no switching on for now. The speaker cover there is cracked. And I think the other one is too. Yep, there it is. It doesn't look like anybody's been in here. From what I've managed to gather, this radio has been in the same family for many years. In fact, since it was bought, so we're probably talking from 1960s onwards. And the challenge is to get this back up and working like new, if not better. Okay, I'm going to get it out of the cabinet and see what we've got. The screws at the bottom have been undone, and I've just noticed that, like some of the other German radios I've done, this one is, the speakers are actually plugged in. So when you remove this, you basically have a free chassis to slide out. I don't see anything else connected, so this one should be quite easy to remove. And here we have it. Lots and lots of dust on the inside, but nothing serious. All the trimming in there is fairly easy to remove. You take off those screws and you can take out the trimming and clean it up properly. But this will stay for now. Get on with the radio first. Again, other than the grime, the faceplate's in perfect condition. No cracks, no breaks, Nothing that a good cleaning won't sort out. The two dial lamps are there. We don't know if they work yet. Some rust on this chassis support. And then the dust starts. There's the filter capacitors, power transformer, voltage selector with a very homemade fuse, a little wire across there in the fuse holder. There we have the two output transformers. Remember, this is stereo. And it's stereo single-ended, so each one of those drives one EL84 output tube. Transformers seem to be in pretty good shape. There's a ferrite antenna, which in this case is rotation. I think it rotates, we'll see. It's stuck at the moment. All that fuzz. The tuning capacitors, the FM and the AM one. More rust on the chassis support. So what I'm going to do now is give this thing a good vacuuming before we even get started, and then come back. Okay, so we got it out of the case, out of the cabinet, and did a bit of blowing on it and vacuuming, and we're starting to see something decent. It's not too bad. A lot of the cleaning still has to be done, but at least the loose dust is gone, and it all looks pretty decent. I've noticed that the dial cord is stuck at this end. Something's wrong there, so we'll have to check it out and see what that is. And here the other side is you can see things a bit better. All the dust is gone. Nothing too obviously wrong with it so far, which is good news. Transformers look great. Okay. So, next step, power supply. I'm going to check out just what's happening here. This power supply came with what may be the original cord, but no plug, no earth connection either. So I'm going to test this first. I won't change the cord just yet, but in all likelihood this is going to have a 3-core cord soon, so we can earth the chassis, make it a bit safer. But my next step is to follow the power supply line through this voltage selector and fuse setup, which doesn't have a fuse, and then we'll see where we are. So to start with the power supply, let's start at the beginning. You get the power cord coming in here, goes in there through a grommet into the back of this, and then it comes up here. These two wires, those two wires are the mains. That brown one there and that brown one there. That brown one has the solder tag here soldered to that green wire. That green wire, if you follow it, goes straight into the transformer, so that's one of the primaries. No switching or anything. The other one comes in here and it goes inside into what I believe would be the switch. So it's going internally. We'll follow that in a minute. And we haven't got to the fuse yet, so we'll follow that and see where we go. So the one that's coming in is actually that black one over there. Comes into the switch, Now this switch has 4 connectors. So this is obviously a double switch, a 2-pole switch. So when you activate any of the push buttons, the power is switched on. When you push the off, it's unlatched and switched off. So from there, one would get this going back to the fuse. There's something else being switched here, which we'll see in a minute. Now the one that comes back from the switch is that green one over here. What it does then is it goes through the fuse, and I've had to put a new fuse in, goes through the fuse to the other side, comes in there, through the fuse over here, goes to that point there. Now that point there gives you an option of connecting it to any one of these mains points with different voltages. The one it's in at the moment, it was on 220, I've put it on 240. Just to play it safe. The voltages will probably be a little low, but we'll check that later. And once it's gone through there, it then goes into one of the respective windings into the primary. So we have a full circuit there for the primary. Where it comes in out of the fuse there is a capacitor to ground. We'll see that in the circuit in a minute. Now that capacitor is this guy over here. As you can see, it's seen better days. This is really to clean up any noise going back into the main circuit, but this particular capacitor is very dangerous. It's not a safety cap. It is rated for 1000 volts DC, 400 volt AC, but as you can see, it's bubbling all over the place. So I replaced it with a safety cap even before going any further. That's always the best thing to do. So now we've got power going into the transformer, and we don't know what's coming out. So the next step will be, I'll take out all the tubes, just for safety. I'll take out all the tubes, and I'm going to power this up very, very gently and see what happens. Right, so I've got this plugged in, and I have the 40 watt bulb activated. That gives us the best protection. It is active, not bypassed. It is off at the moment. The radio has none of the push buttons activated, so it's off at the moment. And I'm going to switch it on, and we'll see what happens. Here goes. That's power on there. Nothing yet because I haven't pushed any of the push buttons. So I'm going to activate one of the push buttons, the FM push button, for example. And let's see what we've got. Not much, which is great, because what have we actually got? We've got, unless we've got something wrong with the transformer's powering absolutely nothing at the moment. It would have charged the filter caps. There'd be no current draw practically because the tubes are out. The heater current would be nil. Okay, the dial lights would work, but they're dead. And I'm not even sure that I've got voltage here. Let me measure that now and see what we've got. Right, so I've got the light box ready to switch on. The radio's on. The light box switch is off, so there's a general cut there. I've connected the multimeter to ground. What happens when we look at the circuit, you'll see that the secondary of the transformer goes into the selenium rectifier. One side, the negative side of the selenium rectifier, is grounded, and the other side, the positive end, goes to one of these filter caps, one of the caps inside this can. So we should see voltage on one of those. Actually, we should see voltage on both of those. There is no real current draw, so we should get a pretty high voltage. Let's see what we get. I've got the multimeter connected to the chassis here, the ground, and switch it on. We've got, there we go, 295 volts, that's one, and 289. So this is obviously the first filter cap, and that is the second filter cap. So we have a working power transformer. Brilliant. So we have our DC supply coming through to the caps, to the filter cap. So the Selenium rectifier is doing its job. We don't know how much ripple there is on there yet, but we'll only know that when we have some current draw. We'll have to have the tubes in circuit. What I want to check now is just because I've got this set to 240 volt input, I want to check what the heater voltage is, and to do that, these two are the heaters. One of them is connected to ground, that's this one on the right. The one on the left is the heater supply. Put that onto AC and let's see what we've got. 7.13, bit high, should be 6.8, 6.3 rather. However, there's no current draw, so we can't arrive at any conclusions just yet. The next step will be to try this with the tubes in place. Now that's always a little bit risky, but we have to give it a go. Now when we do this next test, we're effectively powering this thing up, and it's a little bit nerve-wracking because we don't really know what's going to happen. But what I'm doing is I'm putting the light box, leaving the light box on the 40 watt bulb, and it is the lowest current possible. So we have the highest protection, and what that means is that if there is a short in one of the valves, the current is limited. We will see that 40 watt lamp glow crazily and not dim at all. So we'll know there's something wrong. The other thing is, excuse me, we have to have the speakers connected for this. Never test a valve amp without the speakers connected, because then you have the power tubes trying to activate what is effectively an infinite resistance, impedance. You should never try. It's not a good idea. So what I've done is, because these speakers are in the box and I don't want to take them out, and it uses this connection, I've extended it. I've basically left the speaker box or the cabinet on the floor, and I've put in two extensions here, wired them up carefully, so now I can connect the speakers without having to carry them around. Let's put that in there. Come on. Okay, speakers are connected. The voltmeter is just floating around. We'll test the B plus first. So DC, the meter is connected, the negative of the meter is connected to the chassis. The FM switch is activated, and we actually should hear something. So I'm putting the volume down. If this thing is working, we should hear some radio reception. Okay, let's just hope. Nothing's been done in terms of caps or anything, so I'm not expecting much, but I want to see if it powers up at least. So let's go. 40 watt light went high, and then it's going dimmer again. Brilliant. No shorts. No shorts. Okay. So I'm actually going to probe that first cap. The heaters are heating up the tubes, so what you're getting is more current draw, and therefore the voltage is dropping. That's 133. I'm not sure which one is the higher one. So yeah, okay, that's the first filter cap, 50 microfarads, 129 volts. It's pretty low. I'm going to activate the second light bulb. So basically reduce the resistance in series with the radio, and it goes up. Still no shorts. And let's see if we have any noise. No such luck. No noise, but no smoke. Let's try another light bulb. So there's 80 watts in there. I'm putting another 60 in there. 178. Everything still seems stable. I think it's time to bypass the light box. There we go. So we have a full 240 or so volts going to the radio. And 152, 194. These voltages seem a bit low, which is fine because I'm using the 240 volt input. Let me see what I have on the heater supply. Put that on AC and very carefully probe there. 6.64, a little bit high. No light bulbs working yet, but I'm going to put in some new ones and see if that drops a little bit. The light bulbs themselves draw about 300 milliamps each. I've changed the panel lights, the dial lights. They're both on now. Let's see if that's dropped at all. 6.58, very little. So even with the power, even with the input voltage selected to 240 volts, that'll give us the lowest possible output voltage from that transformer. We still have the heater supply slightly above what it should be. And yet we have the actual VP plus, which is fairly low, 195 volts, and this second one is 153, 195, 153. All right, and we have no joy on FM. Let's try. No noise coming out of the speaker. Oh, okay, there's a hiss on medium wave, and there's a hiss on long wave. A little bit of a hiss on short wave. Nothing on FM. All right. At least we know this thing is not smoking. Let me switch this off. And we know the heater supply is working. There's voltage coming to the cap, so the Selenium rectifier is working. One more reading I could do, let me switch this on again, is actually check what kind of ripple I'm getting on across the caps, the filter caps. So first of all, DC supply, now it's at 200 volts. Let's check the ripple. 4.4 volts. Not bad, but it's a little high. Let me try the second one. This one's completely filtered. 0.2 volts AC ripple. That's a second filter cap. Back to the first filter cap. 4.5 volts of ripple. It's not bad. This is on 200 volts, so it's basically 2% ripple, which isn't bad. It could be better. We'll see if we get hum later to determine whether these caps need changing or not. Hopefully not, because if we could leave it for a while, this could actually reform. Although it is reforming under pretty stressful conditions, it's going up, basically given it full voltage. But I have 200 volts, okay? 200 volts, and I have 156